Okay, guys, this is problem number 6. This is using the graph to solve this equation. If you look at the statement, it had f of x also. That's not really necessary to be there, but it's alright if it is. It's no big deal. I'm just gonna ignore it though because all I really care about is what x values are gonna make this portion true or false. Well, I want it to be true. Okay, so I'm looking at my graph that I graphed in the first question. If you remember back to the first question, I had an asymptote right at +1, right? And I had a 0 at -1. This is -1 here. And then horizontal asymptote was at +1. So it was like this, right? And then remember the graph looks something like this. Approach. Oh, sorry, I forgot to do this in blue. You know, it's okay. Let's just do red this time. All right, so the graph approached the asymptotes here and here, and then on the left side, approach the asymptote right there, and then towards the horizontal asymptote. And then using this graph, I just want to answer this question: when is it less than or equal to 0? And I look at my graph. There's only one part where it's less than or equal to 0. That's this portion right here, right? Remember, this asymptote is at x equal to +1, right? But keep in mind that I can never actually hit +1. +1 is actually not defined. If I put in +1, it's 0. So I'm not going to include that point. And I'm also going to start from -1 because that's where it's equal to 0, and my inequality includes where it's exactly equal to 0. So the answer is just this. It's the interval that starts from -1. That's this position right here where it's equal to 0, and onwards until I hit +1. But not including +1 because that would be undefined in that position. That's just using the graph to figure out what is the solution for it when it's less than or equal to 0. When is my graph below the x-axis, in other words? That's it. Okay, let's try number 7 as well, using also the graph. Okay, number 7 said solve this equation. X over x squared minus 4 is greater than or equal to 0. Okay, this time we're using the graph from question number 2. So if you remember back to question number 2, we had a few asymptotes. We had asymptotes, the vertical ones, at +2 and -2. Okay, +2 and -2. And then we had a horizontal asymptote right at the x-axis, right on the x-axis. And the graph on the left side, we had a 0 right here. It sort of had this shape where it started off top and then switched and then went to the bottom like this. And on the left side, it was, let's see, positive or negative? It was positive. So it was positive up here, right, like that. And over here it's negative, so something like this. Yeah. Let me just make sure that's right. Oh, I'm sorry, I got this flipped around. I was trying to remember the graph by just thinking back to what we did, but I think I should actually double check. So this is -3, that's negative over 9 minus 4 is positive. So actually this part is negative down here, sorry. This is the negative side, and this is the positive side here. Yeah, okay. So now coming back to the question though, when is the thing bigger than or equal to 0? Well, over here it's always less than 0 in this region to the left, right? In this portion, it's bigger than or equal to 0 from -2, but not including that because it's an asymptote, up until I hit 0. So the first part of the answer is that section of the interval. Let's see, here it is. Okay. So the answer then, where is it positive? It's positive from -2, not including -2, up until I hit 0. That's where it's exactly equal to 0. After that, it's negative again, right? The other part where it's positive, bigger than 0, is this entire region from this point, +2, up until infinity. So I'm going to union this with positive 2, but not including positive 2, because again, that's an asymptote. It's undefined there up until positive infinity. So here's your answer right there. Just looking at the graph, observing where is it above the x-axis or exactly at the x-axis. This portion here, including that, and this portion here. Onwards forever. That's it. That's number 7.